Okay, so the first step I do when I blueprint an engine is to map out the head button. The first thing I do is mark down how many shims are included with the engine and the thickness of the shims included. For the Trackstar engine, they include 2 shims, one that measures 12,000 stick, or 0.3 millimeter. The other shim is 8,000 stick, or 0.2 millimeter. Okay, now I've firmly mounted my head button to my engine crankcase on my milling machine fixture. I've zeroed out my dial indicator on the edge of the squish band of the head button. What we're trying to measure here is the actual depth of the squish band that sits inside the sleeve when you put the engine together. What you're seeing here is the outside surface that actually goes down and mates with your sleeve. This is where your head shims will ride. So on the Trackstar 21 engine, we have a squish band depth of 130 thousandths. Okay, I've changed my tip on my indicator to a round ball. What we're going to measure now is the angle of the squish band and the width of the squish band. So I've zeroed out on the outside edge of the squish band. I'll slowly turn my x-axis over until I hit the inside edge of the squish band and measure the height difference between the outside edge and the inside edge. At the same time, we're going to note the distance that we traveled from the outside edge to the inside edge, and that will be our width of our squish band. Okay, so the final step now is to measure the volume of your combustion chamber. I do this by using a syringe that measures a half a cc, as well as a piece of plexiglass and light grease to create a seal between the plexiglass and the outside edge of the squish band. I drill 2 small holes in the plexiglass, one a fill hole and the other a breather hole. I place the fill hole directly above the glow plug, so as I insert the liquid into the combustion chamber, you fill the glow plug cavity first. You fill your glow plug chamber until you see a small air bubble under your breather hole. Once you get to this point, you stop and read your syringe and measure how much volume your combustion chamber holds. On the Trackstar 21 engine, it holds approximately 0.23 cc's. Okay, now that we've mapped out the head button, let's map out the timing sequence inside the engine. The first thing we need to do is secure the sleeve to the case to make sure the sleeve doesn't want to push up when we rotate the engine over to top dead center. I do this by cutting up an old head button to use as a clamp. What we're trying to accomplish here is we need to measure the distance from the top of the sleeve to the top of the piston at top dead center. The distance between the top of the piston and the top of the sleeve at top dead center is needed to calculate head clearance. We'll compare that number to the squish band depth of the head button that we did previously. So once we have it zeroed out and we know we're good, I'll simply crank the x-axis over my milling table till the dial indicator hits the face of the piston. Now I'll check the dial indicator to make sure there's no side load or any binding, and I'll document those numbers. So from the top of the sleeve to the top of the piston, we have 130 thousandths. The next step is to confirm that the piston top is flat. I do this, again, by rotating my x-axis on my milling table to the center of the piston. Once I rotate the milling table over, I'll read the numbers and confirm that the piston is flat, dished, or domed. So as you'll see here, I'm moving it over to center. Again, I'll pick up the dial indicator and confirm there's no side load, and confirm the numbers. Piston is flat. Okay, so the next thing I'll measure is the stroke of the engine. With my piston located at top dead center and my dial indicator set at 0, I'll simply rotate the crankshaft counterclockwise, measuring the linear distance the piston travels from top dead center to bottom dead center. This engine shows a 657 thousandths stroke. So the next measurement we're going to take is we're going to measure from top dead center to the top of the exhaust port. This is your swept volume or your trapped volume of a 2-stroke engine. You need to know this number to properly set up your trapped compression ratio. So I have a flashlight mounted in the exhaust port here. I'll turn that on and rotate the crankshaft counterclockwise. As soon as the exhaust port is exposed, you'll start to see light, and that's the measurement you want to document. Take your time. You can fine-tune it. On the Trackstar 21, we have approximately 415 thousandths from the top dead center to the top of the exhaust port. So we'll document those numbers and move on to the side transfers, or the side intakes of your sleeve. These are approximately 90 degrees to your exhaust port. So with it re-zeroed, I'll pull the flashlight out, relocate it to the bottom half of the crankcase, and then I'll turn it on. Again, I'll rotate the crankshaft counterclockwise, measuring the distance until the first transfer port opens. So as you see the piston going down, you'll start to see the port exposed with the light. There you go. So then you're going to fine tune this. You'll work your way back and forth. And we'll document that number, which is exactly 515 thousandths from top dead center to the top of the transfer. So the next step is to measure the boost port, which is 180 degrees off the exhaust port. So the Trackstar 21 has a 5,000 stagger between the side transfer and the boost port. So the boost port from top dead center to the top of the boost port is approximately 520 thousandths. Now the last step is to measure the rotary intake of the crankshaft. What we'll do here is we'll move over and we'll measure the opening of the crankshaft in relation to top dead center. Which is approximately 620 thousandths from top dead center to the crankshaft opening. Then what we'll do is rotate the crankshaft counterclockwise and go past top dead center. So let's rotate the crankshaft here. Go past top dead center. And now we're going to measure the closing of the crankshaft in relation to top dead center. And we have exactly 205 thousandths from top dead center to where the crankshaft closes. We'll take these numbers and convert linear motion into rotational degrees of the crankshaft. So the final step is to disassemble the engine and get all your weights and measurements off the internal parts. So the first thing I'll start with is the crankshaft. It has a 551 thousandths outside diameter with a 385 thousandths internal bore. The crank pin diameter is exactly 196 thousandths. The total weight of the crankshaft is 38.4 grams. So the next part I'll weigh and measure is the connecting rod. The first measurement I take is to figure out what the rod centers are. This is the distance between the center of the upper bushing to the center of the lower bushing of the connecting rod. By knowing this number, we can now calculate the maximum rod deflection of the engine. Knowing the stroke of the engine is 657 thousandths, and we have a rod centers of 1.161, the maximum rod deflection is 16.5 degrees. The total weight of the connecting rod is 3.6 grams, with the big end weighing 2 grams and the small end weighing 1.6 grams. Something else to take note here on the connecting rod is the factory has opted out to use no bronze bushing at the top of the rod. The plus side here is this reduces reciprocating mass, but the negative side to it is the upper half of the rod will wear out quicker if the engine comes with a lot of mechanical pinch. Luckily, the Trackstar factory has adjusted the mechanical pinch between the piston and sleeve to compensate for the no upper rod bushing. So the engine should break in relatively easy with having a light pinch. The next part to weigh and measure is the wrist pin with clips. I weigh the wrist pin and clips together and I get a total weight of 1 gram, with an outside diameter of the wrist pin of 155 thousandths. The wrist pin can account for more than 20 to 30% of the total reciprocating mass in the engine. The next thing we'll weigh and measure is the piston. The first measurement I take is to measure the outside diameter of the piston. This is 640 thousandths, so this would be equal to what our engine bore is. The next step is to weigh the piston, with the total reciprocating mass of 3.3 grams. Now that we have all our engine parts weighed, let's calculate what our total reciprocating and rotating weight is. Reciprocating weight is your piston, your wrist pin, and your clips, along with the small end of your connecting rod. The total reciprocating mass is 5.9 grams. The total rotating weight is your crankshaft and big end of your connecting rod. Total rotating weight is 40.4 grams, for a total complete assembly weight of 46.3 grams.